Hello, this is your introduction to completing the square. This introduction is based on using algebra tiles to visually see what it is that we're trying to do to complete the square. The pictures below are incomplete. Use the algebra tiles to make each picture a perfect square. So in this first problem, how many 1 tiles do you need to use to create a square? So we would put 1 here, one here, one here, and 1 here. Now my squares are not perfectly sized, but you can see that it takes 4 squares. We need 4 squares to complete the tile, to complete the square. So we want to calculate the length, the length we have here is x, which is the green one, plus 2 more tiles. So we have x plus 2. The width, we have the length of x plus 2 more. So those are the dimensions of our square. Then we want to calculate the area. We have to multiply the length times the width. So we have x plus 2 times x plus 2, which works out to be x plus 2 squared. So if you expand that, you can either use FOIL or there's a formula that you can memorize to put it in standard form. But what you end up with is x squared plus 4x plus 4. Notice that this matches the number of tiles, of 1 tiles, that we had to add in order to get this to be a perfect square. So looking at the next problem, how many 1 tiles are we going to have to use to create a square here? So we have 1, 2, 3, 4 on each row. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So how many total tiles did we add? We added 16. So now our length is the length of x plus 4 more tiles. And the width is the length of x plus 4 more tiles. So we get x plus 4 times x plus 4 to calculate the area, which is x plus 4 squared. Now, you can multiply this out, x plus 4, x plus 4. Use FOIL, use box, use the vertical method. So 4 times 4 is 16. 4 times x is 4x. X times 4 is 4x. And x times x is x squared. So we get x squared plus 8x plus 16, which, again, is the number of tiles that we needed to add in order to complete the square. Both of these examples are considered to be perfect trinomials. Explain why this is true. Why do you think they are perfect square trinomials? Pause the video and write your answer. The shape on the left is represented by the expression x squared plus bx, this one. Our goal is to take it from a rectangle where not all the sides are equal to a square that has equal sides. So we are going to complete the square by adding, so we're going to take half of this b, we're going to move it over there, so we're going to add b divided by 2 squared to the expression x squared plus bx. In each diagram, the combined area of the shaded regions is x squared plus bx. Adding b over 2 squared completes the square in the second diagram. So we take half of this, we move it to the left. So now we have half of bx in each corner, and then we take half of that and square it to complete the square, because that's the number of 1 tiles we would need to add in this position in order to make it a perfect square. So if we're going to add b over 2 squared, and then notice it will always factor into x plus b over 2 inside the parentheses with the squared on the outside. So for the rest of this paper, make all the expressions below perfect squares by finding the value for c. C is our b over 2 squared in each trinomial, so that each one becomes a perfect square trinomial. Then write each as a square trinomial. So let's do the first one together. The equation that you're given is in the format ax squared plus bx plus c. You're figuring out what the c value is. So the a value is 1. The b value, b, is equal to 6. So we want 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So our standard form now is x squared plus 6x plus 9. And then this always factors into x plus your b over 2. b over 2 is 3 squared. Now it's your turn. Pause the video and complete the next 2 problems. For the second problem that you worked, did your final result turn out to be x minus 5 over 2 squared? Check your work. For this next part, you are going to determine if the quadratic is already a perfect square by checking b over 2 squared to see if it's equal to your c value. If it is, then write your answer in vertex form. If it is not, then you're going to add to the standard form and write the vertex form of the equation and identify the vertex. So if we look at the first one, if we look at b, 6 over 2 squared is equal to 9, so it's already a perfect square, x plus 3 squared. So your vertex form then is y equals x plus 3 squared. There is no k value. This is the h value, but with the opposite sign. So the coordinates of my vertex are -3, 0. For the next one, 10 over 2 squared is 5 squared, which is 25. That is not the form of, that's not the c value, so it's not a perfect square. So what we're going to do is we're going to add the 25 so that we can get a perfect square. But anything we do to the left side of the equation, we have to do the same to the right side of the equation. So currently we have y equals x squared plus 10x plus 1. We're going to add 25 to both sides. Y, that's our b over 2 squared equals x squared plus 10x plus 25 Our plus 1 is still there. We've added 25 to both sides. So now we complete the square. I'll do this over to the left since I wrote so large. So now we have y plus 25 is equal to x plus 5 squared plus 1. But we aren't in vertex form until we take care of this plus 25 that's on the left side. So we're going to subtract that 25 from both sides. So then I'm left with y is equal to x plus 5 squared minus 24. That's our vertex form. And my vertex is -5, -24. Now it's your turn. You need to go ahead and finish the remaining 3 complete the square problems that are on this page. You should have these completed and bring this paper to class tomorrow. Have a great day. See you in class.